IDOR is a great vulnerability type because it's often high or even critical impact, yet the bug itself is usually not so complex. However, what often prevents us from finding IDORs is predicting the identifier of another user. It's also not clear to me if an IDOR will be accepted if the authorization check is not there, but you cannot predict the identifier of another user. So that's why I did the case study where I extracted all the IDOR reports from the internet and I studied them. In this video, I will show you what types of identifiers were vulnerable to IDORs. Enjoy! So during this case study, I categorized what type of ID was present in the report, and I have 8 different categories of those identifiers. The most common one was decimal ID shorter than 8 digits. It was about 1/3 of all reports, and it is a very simple case where the identifier is easily brute forceable. 8 digits, less than 8 digits, it's something you can brute force in maximally a few days. But we saw big companies making mistakes with these. Here we have a $10,000 bug in Apple where there was an order ID with 7 digits and it was easily brute forceable, and it's just the most simple version of IDOR. You have a request which takes the identifier, it's a GET request, supposed to read data, and it reads data of anyone, no matter what identifier you put there. So this is the most basic IDOR that we can see, but it was very present. We'll continue with more examples after the sponsor break. This video is sponsored by AppSecEngieer. It's a security training that I can honestly recommend because myself, I took a Kubernetes security course a long time ago before this collaboration. The training was really clear and useful with a lot of hands-on exercises on well-prepared infrastructure. It was a great way to kickstart learning a completely new area for me. They cover all the topics from cloud security, DevSecOps to basic or advanced AppSec topics. They won't bore you with long articles or lectures. They have hundreds of hands-on labs, courses and challenges. So whether you're a security engineer who wants to exploit vulnerabilities, or a developer who wants to learn secure coding, or maybe a cloud engineer who needs to secure complex cloud infrastructure, you will definitely find something for you. To start learning now, go to AppSecEngieer.com. Another case with the simplest ID, we have Yahoo $9,500. And let's keep the setup part of the report. Here the case is a little bit different because I also, in the full version of the case study in BBR Premium Archive, you can also see the different functionalities that were vulnerable to those IDORs and the impact of IDORs. And the interesting thing I saw that reading data was not the most common functionality for IDORs. So the case like we saw before on Apple, where you just send a GET request and you get the data, it's not the most common one because often it was a request supposed to modify something or to change something. Like here we have post to follow some user on some Yahoo application. And in the response, even though this request isn't made to strictly to read some data, in the response, it returns us data of the victim. In this case, it's even an error message, so it explains it a little bit. But it was quite common that it wasn't the simple read operation that was vulnerable. And in terms of ID, we also have the very simple ID. I'm not sure if it's this one or this one being brute force, but doesn't matter. Both are really, really easily brute forceable, and $9,500 for this report. Then the next group was also decimal, but with 8 or more digits. And we also had really, really big companies making mistakes. For example, we have $49,500 back in Facebook. or to be precise in Instagram, and you just had the upload ID, which as you can see is longer than 8 digits. It wouldn't be so easily brute forceable if you had to go through the whole range, because this is 13 digits. But in a lot of cases, when the ID is numeric, you don't have to go through the whole range. You just increment this or decrement this, and you can access data, or in this case, you can change thumbnails of reels of other users, and this attack was rewarded with $45,000 of bounty and $4,500 of bonus. So really nice report. And another case in Facebook, this time in workplace, and here we have a little bit different case, because here again the ID looks to be numeric. We don't really know how long this is, if this is the actual length of this identifier. But here the attacker didn't mention brute forcing the community ID, but he retrieved the community ID from another endpoint. Actually, the hunter mentioned that when submitting the report, he didn't know the way to leak the company ID. So the attack scenario that he used was brute force or using an ex-employee of the company. And this attack scenario is quite interesting. If you have any security mechanism that relies on randomness of the identifier, one of the problems you will inevitably hit is how to take access from someone. Like if you have any object inside the organization, you also usually have the functionality to kick someone out of the organization. But if your security model relies on randomness of the identifier, then you cannot take this from that person. In this case, you would have to rotate all the IDs when kicking anyone from the organization. So when you have a report where the company relies on randomness of the ID, you should always think or write about the attack scenario of removing access of a particular user. Next, we have PayPal, and another case where the identifier is too long to like brute force it as a number, but the identifiers were incremental, so you couldn't go through the whole range, but you could just brute force the particular. Here, I think the hunter enumerated IDs from one of his accounts to another of his accounts, so he would catch all the accounts in between. And here it was quite a severe bug, because you could make transfers from account of another person on PayPal. One thing I want to mention here is be careful when you are brute forcing identifiers. I had this case recently where I started a brute force attack on the identifiers, because I thought my IDOR might work if I hit an account in a correct state, and I wanted to brute force like 20,000 IDs, and I went out to the gym, and when I was out of my home, away from my computer, I thought that if this attack starts working, for example, after 10,000 IDs, and I get 10,000 requests with real user data on the production environment, I might get into trouble, because companies don't like this, and they may not pay you a bounty if you access too much customer information. So it's always safer to just access data from your other account than brute forcing through IDs, even if they are easily brute forceable. With this said, we will go to the next group, which is the name or the email. In this case, sometimes it would be the email is often vulnerable with IDORs in the change password functionality. This is of course very severe, because if you can change the password of the victim just like this, it's an account takeover bug, so it's probably even worse than the IDOR. In this case, it's always $1,200, but there were more severe ones as well. And sometimes the IDORs were just on the name. Here we have the report, which I covered on my channel by Franz Rosen, where you don't actually read the data, you don't actually write the data, but you delete. In this case, he deleted Apple shortcuts, and he actually broke the whole mechanism for everyone on using Apple shortcuts. In this case, he deleted something called zone, and it was default zone. Doesn't really matter what it means. It makes sense in context of this report. And I think he got $28,000 for this bug. As I said, I covered it on my channel, so I will link it down in the description. And another case where you had an IDOR using the name is here on Reddit, where you can access mod logs, and also you just use subreddit name. So this is easier than any identifiers, because you don't even have to brute force anything. You just take the name that you want, and you get whatever data is being leaked to you in case of the IDOR. So this is very simple case. This is easy life for hunters. What isn't easy life is UUIDs. These are long identifiers which sometimes companies rely on their security when they use those type of identifiers, but it's not always a good idea. I've never hacked on Uber, but I think they rely heavily on the randomness of the identifiers, which sometimes doesn't work well. In this case, we have the attack where you can send the identifier and back you get the email. I think some time ago I also saw the sort of opposite of this attack, where you could send the email and get back the identifier, and with the identifier you could get an actual sensitive data. So these are some of the ways that you can do when you have an IDOR but you don't have a way to predict the identifier. It's good to submit some, in this case I think it's a support ticket, to cause some error, to maybe get this information from the error response. But sometimes you don't have to predict the identifier. Here we have Google, and we can see the identifier is long, doesn't look brute forceable. And actually sometimes there are a few versions of those UUIDs, and version 1, for example, even though it looks as equally as random as this one, it's not really that random when you take a look at how it's being created. So long doesn't mean secure, but in this case the hunter did not find a way to predict the identifier, but he didn't have to, because the functionality here was deleting some shareable files. So by definition, when someone shares something with you and you can delete it, you don't need to predict this identifier, because you are deleting something that they've already shared with you. So you can get away with not predicting the identifier in a case like this. But of course, when you can do it, it will always boost your payout. And the next group that I have here is called other non-brute forceable, and there were 14 cases where the report wouldn't fall into any of those other categories, but the identifier would not be brute forceable. And one of the examples we have here is also a bug that I did cover on my channel. It's a bug by David Schutz about leaking private YouTube videos. Interestingly, initially he only found an endpoint to leak one frame of the video, and then he created a script that would sort of recreate the video from those frames. So very interesting attack. But the thing is, it uses YouTube IDs, and YouTube IDs are not considered brute forceable. Here is a YouTube ID. It is too long and too complex to be considered brute forceable. So in this case, David just submitted the report without a way to brute force the ID or without a way to predict the ID. And he even mentioned here that leaking knowing the video ID of someone's private video, it would be a bug on its own. And so the takeaway from this report is, to some companies, you can report the IDOR and you can admit that you don't have a way to predict the identifier, and they will pay you out anyway. But the problem is, before submitting a report, you will have a hard time just knowing which companies will accept this, which will not. And unfortunately, your best bet is probably just submitting the report and dealing with the possibility that they might deny the report. But 100% to companies like Google, probably Facebook as well, I think those big and established bug bounty programs will accept bugs like this. Another example of a value that wasn't brute forceable, but hunters were able to create an IDOR is here. It's a private application which used encrypted values for a lot of things. And I also noticed that sometimes developers use encryption hoping that it will solve a lot of problems magically, and it shows that they don't really understand security and they hope that just using encryption will somehow protect them, but it's often not the case. Like here, the hunters found the way to generate the encrypted value, or to basically they found an endpoint that they could send arbitrary input. We have the change username path, and the response would contain the new username encrypted. So this basically gives them an endpoint where they can encrypt whatever they want. And they knew that their invoice ID, I think, had a specific identifier. So they changed the username to another invoice ID. So they got back the encrypted ID of someone else's invoice. And then they used this value to get this invoice. And that's how the IDOR worked, which showed that encryption in this case did not make things secure. It only sort of hides something from the attacker, but it doesn't really secure a lot of them. And now there are 3 categories left. The next one is hexadecimal, 8 or more digits. So also not brute forceable identifiers. And we have an example here where it's X, formerly Twitter program. But the thing is that the thing I want to mention here is this comment. The hunter referenced 4 different reports with ways to disclose organization IDs. Unfortunately, all those 4 reports are none of these is disclosed, so I cannot see the contents. But it's a very nice place to be, where you can reference 4 different reports with ways to predict the identifier. And one thing I'd like to mention here is, when I do these case studies, I start with the highest bounties and I go down to the lowest. And of course, this is not a rule that's always true, but in general, the quality of reports goes down as I do the case study longer. And one thing that I noticed during this case study, when I was writing the identifier types and ways to predict the identifiers for every single report, I noticed that in the beginning, every single report mentioned the way to disclose the identifier, or if the hunter was not able to predict the identifier, they also mentioned it. But as I went on with the case study to the lower quality reports, there were more and more ones that just didn't mention the ID type. Sometimes the triager would ask the hunter if they can predict the ID. Sometimes they would not, but it just shows that the top hunters, they just think about every single aspect of exploitability of a particular bug. So it's never just, okay, this is an IDOR, it's a high risk. Always we have to think about who can exploit it, how do you know the identifier, do you need user interaction? All those things matter, and you should be taking all of them into consideration when writing a report or when preparing your exploit. With this said, we'll go to the next category where we have other, so something that doesn't fit into any other category, but was brute forceable. And one of those things is a MongoDB default identifiers. They also look kind of random, but here we only see the summary is not a fully disclosed report. We see how the identifier is created, and we can see that this is relatively brute forceable number. So when you see MongoDB identifiers, know that they shouldn't prevent anyone from knowing the identifier of another user. And the other report about this was here. We have the hexadecimal looking value. Unfortunately, we don't see the details. It's mentioned that the hunter mentioned that they broke the cryptographic relationship between the message ID and chat ID. It was supposedly just a simple fixed byte increment. I think I know what it means, but I'm not 100% sure. This was the only other one in this category. And finally, the last category here is a hash value, which is here. And again, the hunter, there are a few reports here. And this is also the case where initially the triager said, or the program said, that they are aware of this, and they closed this report because the hunter did not mention any way to predict the identifier. So, but as you see, this report is in the case study, so finally they had to do something about it. And here the hunter found the way to found an endpoint where they could generate the hash. It was using, I think, the username, or it was using, I found that the username of the hacker is used to retrieve the hash. But again, if the hunter would mention it in the beginning, they wouldn't waste time on the going back and forth with the triager. Maybe they would get a higher payout. There's also a possibility that someone will submit the same report in the time where before you can submit your second response. So there is just a wide range of reasons to just think about everything when submitting the report. So in total, these were the types of identifiers that I encountered during the case study. If you want to access the full article, it's in BBR Premium Archive. Also, remember to check out the sponsor of today's video, AppSecEngieer. And finally, if you want to check another video about the case study, I suggest you this one about account takeover bugs. For now, thank you for watching and goodbye.